My name's Andrew Campbell. I'm the sales engineer for Campbell Wi-Fi tools. And you can find me on Twitter at Wi-Fi Andrew. So when I like to talk about designs, I like to refer to things in metaphors. So in this case, I'm going to compare Wi-Fi design to what I like, sports, football. So what you might be asking is, what does Wi-Fi design have to do with football? In particular, I'm going to talk about spectrum analysis in this case. So football. Let's say you have an offense on the field and the quarterback can't see the defense. What is that going to mean to you? It means you may throw a pass, but you don't know the defender's there. It might get deflected, it might get intercepted, or you might get lucky and you might catch a pass. May or may not work. It's not a great idea to work with an offense that can't see a defense. Same thing works for Wi-Fi design. If all you're looking at is the Wi-Fi networks, network discovery, and you don't look at spectrum analysis, how are you going to know if your network effectively works? You're not going to know the interference, you're not going to know the spectrum utilization, you're only going to know from the offensive perspective. So in football, you also have a number of receivers. This means more receivers, more opportunities to catch passes. A lot of times you have more receivers than defenders. Makes it a little bit easier for the offense. In Wi-Fi design, we work with overlapping channels, non-overlapping channels. So effectively, 5 gigahertz, you're going to have more channels to work with. Your opportunities to connect, probably better than 2.4, where it's going to be more congested. Probably going to have more defenders on the field to deflect your passes. So here, I'm showing a Hail Mary pass. Ironically, my favorite team's the Eagles, so I'm kind of self-deprecating here. But you'll see the Redskins have a lot more defenders than the Eagles do, and they effectively knock down the Hail Mary pass. Same thing happens with Wi-Fi design. 2.4 is often very congested. You have low performance, you have interference, noise, your utilization might be high, so effectively you have more defenders. Football, what I like to call receiver to defender height ratio. You often see on weekends, Calvin Johnson can often jump higher than other defenders and effectively catches more passes that way. Same thing happens with Wi-Fi, with signal-to-noise ratio. You want the larger signal-to-noise ratio, higher the signal-to-noise ratio, the signal strength, received signal strength to the noise floor, the better chance for better performance. So defender ability. Here I'm showing a picture of Darrelle Revis. He's one of the well-known defenders in the league. He's one of the better ability defenders, so it also depends on your performance of a defender. Same thing happens with interferers. Depending on the type of interferer, high power, wideband, intermittent, frequency hopping, what type of defender or interferer is going to affect your signal in a different way. Here's one of actually Eagles doing something right. Blocking. So if you're running a run play, you're going to want blockers out there, try to mitigate the defender's ability to take down your runner. Same thing happens with Wi-Fi design. If for some reason you have a call center with a lot of Bluetooth headsets, doesn't come across too often, but in a dense environment with a lot of Bluetooth connections, you might have some interference. So you might want to switch to a USB headset. Or if you know you have a microwave oven that is constantly giving problems, try to take that interferer out of play. So route timing is also important. In case of football, sometimes your defenders are covering your receivers early on the route, but over time, the receiver is going to get open downfield, so you got to wait for that timing. In Wi-Fi, I like to refer to microwave ovens, where most of the day you don't have interference, but a lot of times around lunchtime, users using the microwave, it could affect your Wi-Fi depending on the time of day. Location of open receivers. So this is showing one receiver is covered, another receiver is wide open. So it's not only the timing, but also where the interference is. So again, in terms of microwave design, the break room might have interference, but that doesn't necessarily mean the whole facility has interference. So that's just a summary slide. Again, if you can't see your defense, can't see your interference sources, number of receivers means, if you have more non-overlapping channels, that's better. Congestion, and number of defenders, signal-noise ratio, type interference, where the interference is, and the timing of the interference. So what makes spectrum analysis important for design? You could identify and mitigate interference, optimize channel plan to avoid those congested areas. Can you even utilize the 2.4 band? A lot of cases, 2.4 is going to be too congested. You want to stick to 5 gigahertz or turn off some of those 2.4 radios. Or can you use the DFS channels for if you see radar signals on your network? So at this time, I would like to jump into a demo of our new 8.5 release that came out a few weeks back. So with 8.5, we now have spectrum integration. So if you want to do spectrum surveys, real-time spectrum analysis, you could perform that now within ESS. Same thing as before. If you want to configure what you're scanning, you click the gearbox on top right. It brings up your NIC adapters. So I have an external NIC doing passive scan. I have an internal adapter, and then now it's showing 2 spectrum MetaGeek DBX Pro Y-SPI analyzers. You could configure which channels they scan. So if you only have one spectrum analyzer, you can only scan one band at a time. You could do a subset of the band, or you could do the whole band. So after you configure what you're scanning, down at the bottom, there's an up arrow, and it brings up this window here. If I hit up again, it's going to show me both bands simultaneously. So I got 2.4 gigahertz on the top, 5 gigahertz on the bottom. Right now I have a 60-second duration scan interval, so it's showing me that the last 60 seconds of scanning, and as it builds, it's going to fill in that chart. So in the middle, I got the spectrum chart, and then I have my signal strength on the top left, my spectrum, what a lot of people like to refer to as waterfall chart. You got the channels on the y-axis and time on the x-axis. And then you got the active ping survey. Right now, it looks like I'm connected to the 2.4 gigahertz network. So you'll see that the 2.4 band is pretty crowded and well utilized. On the right, it shows me the channels, what radios are out there, SSIDs, what technology they're using, and what channel they're on. If I hover over, it gives me a little bit more detailed information, shows me MAC address, what type of radio it is, what the vendor is, what channel it's on, data rates it's supported. Then it shows me channel on the right, signals, and I could also sort these columns if I click. If I click over to the channel tab, it gives me a list of all the channels, the number of radios, overlap, meaning co-channel and adjacent channel. And if I hover over, it gives me a little bit more detailed information. It shows me what co-channel and adjacent channel interference I have, as well as the spectrum utilization and the noise.